Howdy, howdy, howdy. This video is going to cover orbital diagrams, and we're going to look at this diagram first that shows the overall depiction of an orbital diagram. And you can have all the way up to, this is actually an old picture. This was year 2000, so we're actually missing a couple things. We're missing 5F, which is going to be up here. And you got 6D that also needs to be up here, which has 5. So this is a full depiction of what an orbital diagram looks like, but if we look at the axes, on the y-axis we have the principal quantum number n, where we can have values from 1 to 7. And on the x-axis you have the principal quantum number L, which is the shape of the orbital. And what you have here is the S spherical shape, so all these are spheres, the P peanut shape, D, which would be the donut looking shapes, or the daisy, you have 2, and then F is for fancy, and this is when things get a little crazy, but you start having shapes like that. And you also have some shapes that are kind of separated like this that have 2 donuts, but we just call them fancy. You'll notice that the sphere shapes all have 1 orbital, and each one can have 2 electrons. The peanut-shaped orbitals can have 3 different orientations. The D orbitals can have 5, and the F orbitals can have 7. If each line holds 2 electrons, then S orbitals can hold 2 electrons. P orbitals can hold a total of 6 electrons. D orbitals can hold a total of 10 electrons. And F can hold a total of 14 electrons. Okay, so let's practice filling in some of these orbital diagrams. We're going to be using the Aufbau principle, Pauli exclusion principle, and Hund's rule from the previous video. So let's start off with hydrogen, which is atomic number 1. It's got 1 electron. Aufbau principle says I have to fill in first energy level first, and I'm going to put an up arrow here. Now you could put a down arrow. Usually we put up first. That's just kind of the way we do it, but you can put a down arrow if you want. And that's it. That's the orbital diagram for hydrogen. So if I was writing it out down here, I would just want to write 1s with a line up like that. You could also just write it like this. Draw a line with 1s underneath it and put 1 arrow. So let's do the next one. Helium is atomic number 2. So I'm going to put 1 first, which would be hydrogen, and it has a second one. And Pauli exclusion principle says that I have to have equal and opposite spins. So I'm going to go ahead and put the second one here. And the Aufbau says I can't move up to the second row until I filled in the first one. So if I'm doing helium, I would do 1 line, 1s, and I would have 2 electrons. Oxygen is element number 8. So I need 8 arrows, 8 electrons. 1s up and down. I can move on to 2s, and I have to fill in up and down first before I move on to 2p. Now, Hund's rule says that I have to give everybody a piece of candy, so this would be 5th electron, 6th electron, and 7th electron, before I go back and fill in my 8th electron. So if I'm doing oxygen, I would do 1s, and I would have 2. I would do 2s, and I would have 2. And then on 2p, I have 3 lines. Up, 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 and down. And I'm missing 2. And to be satisfied, oxygen's going to have to gain 2 more electrons to be happy. And last but not least will be sodium, which is atomic number, 11. So I need 11 electrons. 1, 2, 3, 4, up, 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 down, down, down. That's Hund's rule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to have one arrow up in the 3s region. So if I'm drawing sodium, I have 1s, up, down, 2s, up, down, 2p, 3 lines, up, 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 down, 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 and then 3s, I've got 1 up. Okay, and those are orbital diagrams.